In this video, you'll see the second set of our 4 core practices. We use these routines at the beginning of every unit. The first practice in this set is getting students to share what they know about an interesting science phenomenon or event. We refer to this as eliciting ideas, but this kind of discourse also activates a lot of prior knowledge so that students can understand which of their past experiences might be relevant to upcoming lessons. The second practice is selecting which of the students' ideas, past experiences, or puzzlements to make part of a public record. And finally, after the lesson is over, the teacher does a quick assessment of how the students talked about the anchoring event and uses that information to adapt further instruction.
These are empty. Okay, so there's nothing in here except for what?
Air.
Air. Okay, so let's make sure this other one's empty just to be super legit. Okay, so what we're going to do is we're going to turn these burners on pretty high and we're going to see what happens. So just like we always do, before we start, I'm going to ask you to make a prediction about what you think will happen. And today is one of those days, if you saw the learning target, you wrote it down, I will be able to record and share my ideas. Today is one of those idea days where it does not matter what you write down, as long as it is about this. All right? So I'm not expecting you to know all the answers to all the questions I'm asking today, but I am expecting you to try to answer them. Okay? So do the best you can. This paper that I'm about to pass out will guide you through that process. So the first thing I want you to do when you get this is fold it in half. That's not working. Fold it in half so that it looks like this. The only reason I'm asking you to do this is that it just makes it a little less overwhelming, and it'll help me focus you on the ones that we're filling out. I need this row and this row right here to step up to these cabinets and that box and grab a pair of your goggles or safety glasses. Make sure they're comfortable and they fit your face. We've got the very, very top line. It says 0 minutes, soda is frozen. Okay, so the 7-Up, I turned it up a little too high. It's actually not frozen anymore, but I want you to draw in that picture where the level of the soda is. I want you to use zoom in circles to draw what the molecules of anything in here that you want to draw is doing. So you might draw, for example, the frozen Coke in the flask. You might draw the air in the empty flask. You might draw the cold ice water or even the ice inside of that bottle that's keeping it cold. You might draw the glass, a zoom in of the glass, the beaker. You decide. Then I'm asking you to predict what will happen with the soda. So you're just telling me what you think will happen. You've got a little bit of a preview there, so you might have an idea. The soda beginning to melt. So if you look at the Coke, there's some liquid Coke and some frozen Coke. It's like an iceberg. So I want you to think, how can you now draw a zoom in of that liquid that's melted in there? It happened again, but I just put it back. Why is that happening?
Oh, I know.
So Food just told us that we have switched already for the 7-Up. It's already boiling. Okay? So it's already set. I'm going to turn it down just a little bit so we can maybe... Oh, what is happening here?
There's too much gas.
What do you see?
Air.
Maybe you could draw a zoom in that shows the steam. Zoom in on that. What would those molecules look like? Make sure you label all your zoom ins.
I'm thinking about
Okay, hey, so something else just happened. That just went past my arm. It was hot. So that's something else to notice. That's an observation that I was hoping not to make. Okay, so Alano just asked a really good question. He asked, what happens if you take it off? Will it still boil? And look, it's still boiling. So it's still bubbling. Why do you think that is? What are those bubbles?
Molecules.
Those are big molecules.
Like it's a bubble cast with the...
I heard carbonation, I heard molecules. Add your explanation. How can you add that? How can you do that? Draw a zoom in of those bubbles maybe, or write another observation.
It's the less that still has
That pressure in the bottle because of the air. That the air pushes the top.
Just draw a zoom in circle there. So see how Delbert's drawn the level of the soda in when it's frozen? So now I want you to draw a zoom in circle that shows what the molecules would look like if you zoomed way, way in. That's fine. Just draw your little point, show where you're drawing that zoom in from. And what do you think those molecules look like? So what's the movement like? And how are they arranged? How much space is between them? Yep, of that frozen. You are ready to move on.
How did you draw yours?
Box.
They're pretty close together, huh? Why'd you draw them like that?
Because it's cold, they have less room, but they're still moving really slow. If it's frozen, they must be really slow. And
How do you know, like when I look at your picture, I don't know that they're moving. I just see circles.
I put some lines in.
You put some like shaky lines? Alright, I got it.
In this classroom, we can hear students purposefully using prior knowledge to make meaning out of what is happening in this distillation. As we listen, we'll hear them drawing on many resources, including previously taught science ideas, everyday language, things they've seen on TV, and other experiences that they've had outside of school. They'll even generate their own analogies in an attempt to make sense of this anchoring event.
What are those?
The molecules.
What are they doing?
They're like, I think that when it starts to boil, the molecules are gonna make the soda start boiling when it heats it up.
Yeah. Look at that. That's pretty cool, huh? So how does your molecule idea explain what just happened?
Maybe on the other one, maybe on this one, maybe there's too much steam. There's too much steam from this one going through the tube on this one, and then making the thing going up.
Yeah?
So that's why it's making the thing getting off of the thing.
So the molecules and steam?
Yeah, the molecules and steam are like
Okay.
the steam is going up the tube going there, and all the steam is mostly going in here and popping the thing off.
So what you just told me is what you should write down, because that was really great. So you said the 7-Up is pushing steam into the bottle, and that's what's making it pop off. Why is the steam making it pop off?
High now?
Because it's not pressurized. Maybe we should crank it up.
Why don't you just draw a picture?
I'm coming back to that, because you said it's pressurized. What do you think? You want to think for a second? Alright, what do you mean by it's pressurized?
Building up pressure to where it makes it pop up.
How does steam build up pressure?
Because the molecules
Yeah?
get out.
You choose.
Oh,
You should probably write about 7 up.
That's how the pressure comes.
okay.
This is 7 up.
Okay, did you write about that on your paper? Yeah, you're going to. Because I think you're the first person that I've heard talk about pressure. So the amount of pressure makes you able to see the air? Okay.
The top on the bottle is blocked off.
Yeah.
There's so much air pushing into the bottle.
It pushes out.
Yeah, it pops the thing because there's so much air in the bottle.
Okay, so you just said it like 3 times. So what's it? So when the air goes into the bottle, what does the air do in the bottle?
There's so much air that
Okay, there's so much air now.
Molecules move with molecules that
it starts packing up in the bottle.
Okay.
So it pops the top
The
off.
air starts packing up in the bottle.
There's so much air in the bottle that the pressure that the top of it.
So there's so much pressure in the bottle because of the air that the air pushes the top off. Okay.
And the liquid molecules are the air molecules are bringing liquid molecules up to the tube and transferring it into air molecules into the other bottle.
Okay. That's a really sophisticated theory. Is that what you wrote?
Yeah.
Let me see.
Okay, so
Alright, Daniel, you made an observation that it's not brown. Why do you think it's not brown?
Cause mostly like the water, like it's mostly like the Coke is still boiling,
Yeah?
and it's mostly like the steam that's coming out, and it's making like water go through the steam. So it's mostly like boiling, and like the molecules are like making the Coke have some movement, and like the steam is going through and going through the tube and making the like the other side thing pop out.
So I think I know what makes the Coke brown then. Where's your warmer for today? Can you open to your warmer for today? Look what you wrote down.
Food coloring.
That might be what makes Coke brown, right? I got that from you.
So we just had, somebody just shared an idea with me. They said, they're talking about the steam. So they said the reason something's going through this tube is because the steam is pushing it up, so it doesn't have anywhere else to go. And I said, okay, so what's going to happen when the steam gets to the cold flask? Okay, may I share your idea? So Alicia said that she thinks it's gonna be water again. So it's gonna look like water. So we're about to test that. We're gonna see what's in this flask. Okay. Whoa, look at that. That was not in there when we started. Do you think that's water, or do you think it's something else?
Water. Water.
So now you've got something else to draw a zoom in of.
Taste it. I bet that's like.
It's like when you sweat.
But let's see. Let's look at the Coke. Let's look at the Coke. What do we got over here? What do you think?
Nothing.
Whoa.
I will call that.
Clear, at least.
Daniel's got an idea about why it's clear.
Sweet, Daniel. What do you think is clear?
Because mostly like when the Coke is boiling, there's like molecules. The molecules are making the Coke have some movement, and mostly like the steam is going through the tube, and it's making it's mostly like the steam is turning into water when it goes through the tube, and it's mostly having like the water go through the tube and go on the other flask.
So are you saying that this is all water that's in there, the clear liquid?
And what did you say in your warm-up that's in the Coke that's not going over to the other flask?
The sugar. The food coloring.
Do you think they put water in the Coke?
Coke getting boiled.
I don't know. Maybe.
Well, what do they put in the Coke?
Maybe.
They put like sugar, they put like carbonated water in it.
The Coke?
Okay, so but they have to put some kind of liquid, right? Because otherwise they just get high of sugar.
Yeah, maybe it's taking out it's leaving the best of the food coloring and sugar in there, and it's putting all the other stuff it's separating the ingredients. You know how they said that they put a bunch of ingredients like food coloring and sugar, and I think they put carbonated water. I said they put water. You said they put water. Yeah, but so it's club soda. Yeah. Okay. So it's separating the food coloring and the sugar from the carbonated water. So how is that possible?
Well, tell the screen your prediction.
Prediction. That's right.
Yeah, tell your prediction.
Have you ever watched what's it called again? No. Dual server. They take some of their piss and some of their they put it into the thing, right? Then they put a bag over it. Then it made the sun heated. Then somehow when the sun heated it the next day, they dropped some water that came from the bag dropping down.
What did they do with that water?
They drank it.
Oh my gosh. And it was pure water?
Yeah,
How do you think why did that work?
Maybe because the sun heated it.
How is that like what we're seeing?
Well, you guys are talking about something similar. Because what's your prediction? Because I bet
Because there's water in everything, or
What's your prediction about what's eventually going to happen to the Coke in this flask?
it's gonna turn just into food coloring. It's gonna go very it's gonna have.
Well, hold on, because I hear two different ideas. So I hear you're saying it will all eventually turn into water, and you're saying something different about the food coloring parts of it. So tell me what you think will happen to the food coloring.
I'm saying that in the food coloring, it's just gonna stay there. So you're gonna see all dark of the color, and in the other one, you're just gonna see the carbonated water. I don't know.
It's like heating it. It's making like kind of like when you sweat, and like it makes like little bubbles that go through the tube, and it's like dropping in there.
You know,
Kind of like air.
you know who else talked about sweat?
Yeah, Alana was talking about
Yeah.
sweat too.
Yeah.
So you guys have some similar ideas happening here.
It made. Did you hear it make a whistling sound too?
What's that like?
Yeah, it made a whistling sound. What did it sound like?
Like a teapot on the stove. It's kind of like when the clouds the water from the ocean and transfer over the Cascade Mountain. That's because it fell in that water.
Look at the 7-Up.
I didn't know so was
It's all out.
Oh, it's not white. It's not.
It's the best stuff.
It's
clear, not white.
Let me see.
Try to guess.
The steam comes from hot water. All right, ready? Period. Why? Because. Then you write.
So third period, you have the tools to answer all the questions on the paper and draw one zoom.
Is the steam inside the water? Where?
Like something gets hot, like in the room, like the temperature gets hotter and
So like when it's really hot, you say that it's boiling, or what did you say?
Molecules change.
Is that the same thing, that it's really hot in a room and the molecules change?
This lesson has activated students' prior knowledge and allowed Anna to hear what resources they were using to reason about the anchoring event. Here are some specific examples of resources that students used, many of which were generated because Anna has routines in which her kids expect to share their initial ideas, and they have tools to help them do that. Hearing these ideas is a start, but it's only the start of ambitious teaching. Anna now has to ask students to make their ideas public, to organize them, compare them, test them, throw some out, and combine others. This is all part of sense-making that will happen throughout the unit.
Right.
This class is awesome.
It is awesome. That's why I'm here.